In this video, I'm going to solve two different exponential equations using two different approaches and just contrast these two equations. So with the first one, we've got 3 to the 2 minus x equals 22. One thing to consider when you're starting out solving an exponential equation is it possible for me to write both sides of this equation as a power of the same base? There's a property of exponents, it's the one-to-one property of exponential functions that says if we can express an equation in the form b to the u equals b to the v, so as exponential expressions with the same base on either side of this equation, then we can drop the base in each one of these expressions and just set the exponents equal to one another. And that's always a more straightforward method of solution. So it's always wise to start out considering, okay, can I express both sides of this equation as a power of the same base? Well, 22 is not a power of 3, so that's not something that we could do easily. So instead of this approach, in this case, plan B is to take advantage of the inverse operation of exponential expressions, which is logarithms. If I want to get rid of the base 3 here, well, one way I can do that is take a logarithm of both sides. Now, it turns out you can take any logarithm you want of both sides as long as you're consistent. In a lot of online homework systems, it'll ask you to write your answer in terms of a natural logarithm or in terms of a common logarithm. So make sure you pay attention to the instructions in those homework problems. I think that what you might see in your homework this time is an instruction to write your answer in terms of the natural logarithm. So you can take any log you want, for the record, of both sides. I'm going to take the natural log of both sides of this equation. So natural log of 3 to the 2 minus x equals natural log of 22. The advantage of taking a logarithm of both sides is now, thanks to one of these properties of logarithmic expressions, we can take this exponent and bring it down in front. So now you can write this as the quantity 2 minus x, and you need to make sure you put parentheses around that because it's the entire expression 2 minus x times natural log of 3 equals natural log of 22. So now we no longer have an exponential expression to deal with. Now the x is on the same level as everything else. So that's going to make it easier to isolate x in this equation. Natural log of 3 is just some number. It's some irrational number, but it is just a constant multiple here. So we could divide both sides by natural log of 3, and that'll cancel the natural log of 3 here. So we have 2 minus x equals natural log of 22 divided by natural log of 3. And then there's different ways you could approach this from here. I'll subtract 2 from both sides. So I have negative x equals natural log of 22 divided by natural log of 3 minus 2. And then multiply both sides by negative 1 or divide by negative 1, however you want to look at that. So I'm going to multiply both sides of this equation by negative 1. Now, when I do that in writing my final answer, I personally prefer to write my positive term first. So when you distribute this negative 1, you're going to have positive 2, so I'll write that in the front, and then negative natural log of 22 over natural log of 3. And there's your final answer, expressed in terms of the natural logarithm. We could have just as easily, for the record, taken log base 3 of both sides if you want. That works out cleanly on the left side. It makes the left side look kind of nice. If you take log base 3 of both sides, then this side will become just 2 minus x. And this side would be log base 3 of 22. Or you could take common log of both sides. Okay, but here's the answer in terms of natural logarithm. I want to move on to this second equation over here. So again, if we start out by just considering, can I write both sides as a power of the same base? Can I write this equation in the form b to the u equals b to the v? It's got to be a single exponential expression on either side that will allow you then to drop the bases and just let the exponents equal one another. In this case, we can. We can express both sides of this equation in terms of the base 2. That's going to be the most convenient base to work with. We can express the square root of 2 as 2 to the 1/2. So we've got 2 to the 1/2 raised to the x. Now the 16 on the other side here. Well, 16 is a power of 2. It's 2 to the 4th. And if it's in the denominator, we can write that as 2 to the -4. So there's a few properties of exponents that are going to come up in this solution, and I think I'll write them over here. So one of them is that if you have x to the a raised to the b, that's equal to x to the a times b. While we're talking about it, if you have separate exponential expressions, x to the a times x to the b, that's equal to x to the a plus b. And 1 over x to the a is equal to x to the -a. So this last one is what I'm using here. So 1 over 2 to the 4th is equal to 2 to the -4th. And this property here, so 2 to the 1/2 raised to the x is 2 to the 1/2 times x, which I could write as x over 2. If I multiply straight across, 1 times x over 2 times 1. And look, now you have it in the form 2 to the something equals 2 to the something. So now you can set these exponents equal to each other. Now we can say, all right, well then the exponent x plus 2 must equal the exponent on the right side here, -4. And so in order to isolate x, I'll multiply both sides by 2. I don't know why I put the x there, that's a little confusing. So that'll give you x by itself equals -8.